Now in this video we'll try to see the issues with the layer 2 multicast, and then we'll see the solution called IGMP snooping here. So our main focus will be on IGMP snooping. But before we go ahead, if you remember, in the previous video we have seen that whenever you are sending any multicast traffic for any group, it's going to convert into equivalent layer 2 MAC address. Okay, but now the problem here is, let's say if there is a host or a receiver who wants to receive the multicast traffic, he's going to report to the first hop router saying that I want to receive the multicast traffic for so and so group, and the router will figure out the source and it's going to receive the multicast traffic, and then the router is going to forward the multicast traffic. So but when the router is forwarding the multicast traffic, the source address will be the source address will be the router address here, and then the destination address will be always the group address. So let's say the group address is 224.5.5.5 and it's coming from the router. Now based on this, it's going to, there is a protocol called ARP which is going to resolve the equivalent MAC address, because the switches do not understand the IP addresses. But now here the equivalent MAC address is converted by the multicast protocol here, and the equivalent MAC address starts from 01005E, and it can be anything based on the group address here. Now the problem here is the switches do not know exactly. If you verify the show MAC address -table, normally here you don't have any host connected with this MAC address, so which means automatically the switch do not know exactly where to send. Now there is a possibility of this particular traffic is broadcasted instead of sending only to the receivers. Now I got two receivers who wants to receive the multicast traffic, but as the switch do not know exactly where is this host connected, there is a possibility that it gets broadcasted, which means your traffic in the LAN may get broadcasted if you do not have a mechanism, or if the switches do not identify on which ports the receivers are connected who wants to receive the multicast traffic, on which ports we don't have receivers. Now there should be some solution to overcome this drawback. So the major drawback is it's going to waste the bandwidth, because the switch is going to flood the multicast traffic out of all the ports, because it doesn't know exactly where the host who wants to receive the multicast traffic are connected. Now the solution is IGMP snooping. So IGMP snooping is a standard way to provide the information, or the switch is going to learn on which ports you have a receivers connected, on which ports you don't have a receivers, on which ports you need to forward the multicast traffic, on which ports you should not forward the multicast traffic. There is also a Cisco proprietary method CGMP, and they do the same job. They work slightly different, but IGMP snooping is the default feature enabled on all the switches, and it's a standard based solution for this. Now the main job of the IGMP snooping is to determine on which ports you have a receivers connected, on which ports you don't have a receivers connected. So when the router receives a multicast traffic, it's forwarded to the switch. Now the switch knows exactly that the multicast traffic is coming for this group, and what are the particular devices who has requested for that particular group, and it's going to forward only on the ports who are requesting for that particular multicast traffic. Now it's going to do this based on the IGMP messages. Like, it's going to keep monitoring the IGMP messages which are going between the PC and the router. Now this IGMP feature is going to dynamically determine which host connected in the particular VLAN who wants to receive the multicast traffic for a specific group. Now the switch is going to examine the IGMP messages, learns, and the location of the multicast router and the group numbers. Like here, let's say this user is going to send some join message, just a message reporting to the router saying that it wants to receive the multicast traffic from this group address. Now the switch is going to keep monitoring these messages. It's more like, it's snooping those messages or listening to that messages, and it will identify that there is a IGMP request coming from this port, let's say port number 1, and also there is a IGMP request coming from port number 3, and it's not on port number 1. So the switch is going to keep the information, and it's going to write down that on port number 1 if any traffic is coming, and it's going to write down the equivalent MAC address for that particular group on port number 1 and port number 3, in the MAC table. And then the request goes to the router, and the router is going to send back the information to the switch, and the switch is going to see that when it is sending, the destination address will be the MAC address of the multicast group, that is 01005E, and then it is going to simply send out of port number 1 and 3 because these are the two users who has requested the multicast traffic. It's going to send out all these two ports, and that's how it works. And if any user do not want to receive the multicast traffic, he is going to send the leave message. Probably the switch is going to query. Now again, based on the leave and the query messages, the switch is going to realize that this host wants to leave the group, and automatically it will remove that entry from the MAC table. So this is a dynamic method, and this IGMP snooping feature is something by default enabled on the Cisco Catalyst switches. Now, if you want to specifically enable it, we can use a command called IGMP Snooping, or we can even enable for a specific VLAN. So if you want to disable this feature, probably that is something we don't want, but you can always use no command before that. And for verifying, we can always use a command called show IP IGMP Snooping for the VLAN or for the interface. You will see IGMP Snooping is enabled.